A new day with lots of sun and people are on the move. When solar panels produce the most electricity, no one is at home. And when people return to their homes, the sun is about to set. Demand and supply are not in sync, a basic problem for renewable energy. The network is supposed to transport power to where it's needed at the moment. But the existing power lines are overloaded. They can't take on any further green electricity. The expansion of renewables is endangered. Help could come from a combination of solar panels and lithium-ion batteries. These high-capacity batteries can store solar energy for longer periods of time, relieving the strain on the network. The problem is, batteries like these are expensive. One way to make solar power storage more economical is to increase the efficiency of the entire system containing the solar module and battery. That's why scientists and engineers at a Munich semiconductor company are working to make the flow of electricity between the solar cells and batteries as loss-free as possible.
We know that the price for lithium-ion batteries will come down over the years. Nevertheless, an important challenge will remain, which is to make sure that all the energy that is generated by the solar module is effectively stored in the battery, which means we need to have an energy transfer chain which doesn't lose any energy at all.
The problem is, lots of sunshine causes the solar cells to deliver lots of electricity at a high voltage. And when there's little sunshine, the cells deliver little power at a lower voltage. The batteries, however, need a constant voltage level for charging. That means the voltage of the solar modules has to be lowered or raised by several hundred volts without any loss of energy. To make that possible, semiconductor engineers manufacture special microchips in a complex process. The chips are only a few thousandths of a millimeter thick. Several hundred fit on this wafer. The ultra-thin chips work like a switch and are part of an electronic component. And this component is integrated into a special electronic unit that has the task of providing the battery with just the right voltage. And it manages the flow of electricity with as little power loss as possible. If there's lots of sunshine and the solar cells are delivering a lot of power at a high voltage, the switch closes only for a short time. The result? Electricity flows into the battery at a lower voltage than it comes out of the solar module. If, on the other hand, the solar panel delivers power at a lower voltage, the switch remains closed for a longer time period. This results in electricity flowing into the battery at a higher voltage. That means the silicon chip always adjusts the voltage to exactly what the battery needs. And since the chip is just a few thousandths of a millimeter thick, it offers practically no resistance to the power. As a result, energy flows through the chip with almost zero loss.
With the new thin wafer technology, we provide the solar industry with a new and much more efficient way to store solar energy.
Ultimately, the system of solar cells and energy storage becomes more economical. As part of a European pilot project, the use of this technology is being tested in several private households. For example, in this family home in Bavaria. Here, Fraunhofer scientists are testing a brand new system. For the first time, they're combining into a single unit the electronics that bring solar power to the correct voltage with the batteries that store the power. The entire unit is the size of a small cabinet that would fit in any garage or basement. The efficient electronics regulate the flow of electricity between solar cells, batteries, and the power network. When the sun shines, electricity flows into the home's power lines. Just enough to power the dishwasher, refrigerator, and washing machine currently in use. When the cells produce more electricity than currently needed, the excess solar power flows into the battery. If no one is home and the washing machine isn't running, the solar power also flows directly into energy storage. After sunset, the battery provides the house with electric power. In this way, solar power provides around 80% of a family home's annual electricity needs. During this experiment, the new technology remains under scientific observation. The goal is to make the combination of solar power and energy storage more economical with the help of efficient electronics. And if the new technology takes off, it will benefit more than just private homeowners. PV battery systems take the strain off power networks. They spur the growth of renewable energy because locally produced electricity is also used locally. If solar power is both produced and consumed within households, that reduces the amount of electricity that has to flow through the power lines. That leads to greater network capacity, making room for more renewable energy. And maybe when night falls in the future, we can just turn on the sun.